afternoon, everyone. As you heard, my name is Simon McCulloch. I'm the channel manager for F5 Networks for Sub-Saharan Africa. F5 is an application services company. A lot of people, when they hear the name F5, they think load balancer. Load balancer is one of the services or application services that we provide. And today we'll be talking around how do we mitigate against advanced threats on our applications, specifically when we're starting to migrate workloads into public cloud infrastructure such as Azure. And if we also are hosting applications in our private data center. We have a threat intelligence report which we have looked at data that has been over the last decade. And from that, we analyzed a whole lot of cases across countries in a multitude of industries, including tertiary institutions. And we found that web attacks are the #1 cause and single point of breaches in our infrastructure. 53% of attacks have happened at the web application space, followed by 33% at the user credential space. Why is this? Well, it's clear and simple. It's because applications are the gateway to your data. This is where the criminals and the bad actors, and when I mean bad actor, I don't mean Nicolas Cage. I mean, the likes of the types of hackers and guys that are trying to get in there to steal your data. They're using credentials or the application to get to that database. What's critical, though, is that you need to understand the application, understand how your application operates, both from an architecture and operating system perspective, and things like encryption. What kind of encryption are you applying? What DNS is in use? How's the network configured? These are all different points of attack for the attacker to hit your infrastructure to get to that data. What we're seeing is that organizations are starting to change the way that they approach security. It's no longer about perimeter security and making sure that I've got a firewall in place that's keeping bad connections out and making sure I'm allowing connections on certain ports, etc. We now need to look at changing that security, especially because we're starting to move workloads out of the perimeter and into the public cloud. It's more and more critical that we start protecting the application itself. An app-centric security approach is about ensuring that you can control the access to the application, that you can protect the credentials that is being used for that access, and prevent fraudulent activities. If it's a web application, we need to provide the protection against that. And then, of course, to keep it up, we need to make sure that we've got some denial of service mitigation services in place for this. What makes this difficult, though, is that we have different development teams working on our web applications. Our web applications, or our web developers, when they're developing an application, would generally reference what we call the Open Web Application Security Project, or OWASP for short, and reference the top 10 vulnerabilities and code against those vulnerabilities. This becomes really difficult and expensive to do because vulnerabilities are changing all the time and becoming more and more complex. We're also finding that they're having to recode legacy applications, which makes it extremely difficult because there's multitudes of lines of code to go through. And then, of course, as you've recoded something, the underlying operating system changes and then new vulnerabilities are introduced. So there are better ways to do things, and you need to ask yourself the questions. First of all, do you have legacy web applications in place? Are you still running web apps on IIS, for instance, as an example? There are certain vulnerabilities in there that you just cannot patch. Have you got difficulty in getting your software stacks upgraded? And if you have coded your application with the top 10 OWASP threats in mind, can you guarantee that the third-party libraries that you are pulling in or referencing have been coded the same way and do not have those same vulnerabilities in place? What about development and time to market? If you're developing a new website for students, are there timeframes in which you need to meet it, and will those complexities allow you to meet it in time? And we'll find quite often when people have got short timeframes in which to meet something, shortcuts are made, and vulnerabilities are in that application, right? The other thing that we need to really contend with are bots and automated scripts. We're finding that majority of traffic on the internet these days is bot-related, and of that, quite a bit of it is malicious bot activity. We'll go into that a little bit later. And then, of course, in South Africa, we've got the POPI Act, which is going to be coming into enforcement sometime soon, or in South African terms, now. We just, right? Just now. But this is something that we need to take into consideration. Think about students. How are we protecting private information? Identity numbers, bank account information. If somebody's accessing a web report, can they hit it with a SQL injection? Can they pull that data out? Or could they just pull a legitimate report and get access to student information, such as ID numbers, marital status, all this private information that we now need to show that we are protecting or keeping private. And then, of course, we've got those situations where IT really go pale and stop breathing, these zero-day attacks when there's no patches available, and we're being hit with all sorts of attacks, and it's panic stations. And as I mentioned earlier, if you've got highly sensitive data that you need to keep confidential, if you've got any of those requirements, you need to be looking at what we call a web application firewall. Now, a lot of organizations will say, hey, I've got my perimeter security in place, I've got my perimeter firewall checkpoints or ASAs. What makes this different is that this is protection on a per application basis, and it has where a web application firewall has a much deeper understanding of how an application operates and what it needs to protect against versus perimeter firewalling, which is very broad and shallow. So a web application firewall, just as a quick introduction, if you have not heard of these, this will protect you against application attacks, the top 10 OWASP, and more than that. We do reference the top 10 by default, but will help mitigate against things like credentials being stolen, SQL injection attacks, cross-site scripting, any application vulnerabilities. For instance, if you have a website, when your website responds to somebody, if there's an error, you don't want that website to tell that user what, if it's Apache or Microsoft, because they can easily reference that and see what vulnerabilities that website of yours has and then attack it. So we can start hiding that kind of information. Payment card information. Do you have an online portal where students can purchase things online? If you do, it's critical that you protect that credit card information from being breached. And then, of course, as I mentioned earlier, any confidential customer information or mission-critical applications. And that's regardless of where that application resides. You need to have the security in place to ensure that once that application moves from on-premise into the Azure stack, that you can rest easy at night knowing that your data is not being compromised. We had a customer last year who did not do this, and their DevOps team was coding an application and had it in a public cloud in Europe. They were doing this for the NHS, National Health, and they finished coding the application, put it into user acceptance testing on-prem, and then deployed the application, and they forgot to tear the application down in the public-facing domain. And that was breached, and 60,000 records were compromised as a result. So it's critical that you protect. Web applications, and the way that web application firewall is designed, it will stop the attack before it even hits your application. We do this by checking things. Is it a legitimate user connecting? Is it a bot? We can actually challenge it. Well, when I say we, I'm not intelligent enough. It's my appliance that can do this. We can check, are you a bot? Are you human? Have I seen keystrokes? Have I seen touches on a phone if it's a mobile application? Once we've determined whether it's a user, we'll then present the application to the user. The user can never talk directly. They have to talk through this appliance, and it's a full proxy. A full proxy, of course, means that I've got data request coming in. It terminates, and the appliance starts a separate connection down to the backend service. And when the server responds back to the user, again, we terminate and start a separate connection. It's a very good security stance to have. It's almost like having no man's land and somebody operating in the middle there, making sure that we've got a translator talking between the two entities and they can't talk directly. I'm going to go through this quickly because I've only got 20 minutes. So, as I mentioned earlier, provide that coverage for the top 10 OWASP threats. This is a very good alternative to code reviews because this is zero-day patching and protection for your applications. What we do is a web application firewall will go into learning mode. It'll look at how a user requests information from a web app. It looks at how that web app responds and then starts reporting it back. These are the known vulnerabilities, and all you do is say, I want to go into blocking mode, and it automatically will start blocking against those vulnerabilities. And of course, you can then customize it to add certain additional things as needed. This also allows you to fix vulnerabilities without maintenance windows. So often when we come across a vulnerability in IT, we have to wait for those change controls or those change periods and then load it up and hope that it works and we don't have to roll back. From this perspective, if you're using vulnerability tools or assessment tools like VAST or DAST, so Qualys and White Hat and all these assessment tools, you can take the report and you can import it into your web application firewall, and it provides immediate patching against those vulnerabilities that have been identified. This, of course, it doesn't mean that we're going to get rid of the developers. We are freeing up the developers to focus on application development and not having to worry about if they've mitigated against those vulnerabilities. A traditional web application firewall, of course, is going to protect against those, as I mentioned. But what I want to talk around today is what we're doing in the advanced web application firewall space, and this is something that only F5 can do. So I've spoken about the OWASP top 10. I'm going to go through that. So our traditional web application firewall, of course, mitigating against those three things, which was the OWASP top 10, vulnerabilities, etc. What about where we've got automated attacks, bots? What happens if somebody's using a mobile application? And what if somebody's actually hitting us with legitimate requests, but they're hitting us in such a way that they're actually slowing us down with what looks like legitimate traffic and creating what we call a low and slow denial of service attack? And then also, more importantly, the one thing that we tend to forget about is our APIs, whether they're third-party or ours. What are we doing to protect those vulnerabilities? So if we look at what F5 is doing in this space now, as I mentioned earlier, just to set the scene, we've got this full proxy architecture. I've got my users connecting in from the left. That's going through the OSI stack, and then, of course, the OSI stack back down into the server environment. And we generally focus on layer 4 to layer 7 security from an F5 perspective. So this is also about making sure that the SSL inspection is happening, that we're not allowing encrypted attacks to come into the environment, and that we don't have SSL denial of service attacks. And then, of course, application monitoring of the health to make sure that the application stays up. Our bots, we can do some amazing things now. You know, we have good bots and we have bad bots. If you catch me out in the nightclub tonight, I'll show you a really bad bot. But we have good bots and we have bad bots. So we've got the likes of bots from Google who do web scraping, come see websites, catch keywords, etc. When somebody says, I'm looking for a university that offers the following courses, a university is going to come up, and that's web scraping that's happened. But then we've got bad bots, of course. We've got the likes of malware. Bots are there to plant malware onto your device. They're used for denial of service attacks, and they can be used for automated scripted attacks. We, as in the appliance, can now detect whether it's a human or bot and go one step further and start analyzing and seeing whether it's actually a legitimate bot or whether it's being impersonated. So is it actually a Google bot that's busy scraping my web, or is it an impersonating bot? We can also do what we call client fingerprinting. It's not just about looking at the IP address that a device connects on these days. When a device connects, we can fingerprint it so that if the IP address changes, we still know whether that's a bad device or a good device that's trying to connect into our environment. And at the same time, monitor the performance of the server to make sure that If a bot is interacting with the server, and we see that the server is starting to respond in a negative way, we know that this is malicious. The other thing that we need to be aware of, and it's our users. The users are the single point of failure when it comes to security. Why? Because you can put all the perimeter security in place, you can put in the web application firewall, IDS and IPS, etc., and then your user doesn't have an antivirus on their machine, or they've got malware, and they're logging onto your website, and they think, hey, I'm connecting on HTTPS, I'm secure. No, you are secure when you are connecting to the server. When you're working with your browser, you are working in clear text. Do yourself a favor, go check out your internet banking, or go check something like Takealot, and right-click and inspect the code, and you can see the username and password fields clearly there, and as you type in your username and password, it's in clear text. You can see it easily. Malware is designed to capture that, and you can immediately, as a user starts typing, username and password field, it records and sends it to the hacker's drop zone. In the meantime, you've logged on and your accounts are being compromised. I would suggest you also, as a side note, go look at Have I Been Pawned or Pawned. It's Have I Been, P-W-N-E-D. I've got another page that's coming up now. Go and put in your email addresses that you've ever used. I promise you'll find at least one of them. You've been compromised. You need to go change your passwords. We've had a couple of breaches in South Africa in the last year or two. ViewMyFines.com was breached last in May, or a couple of weeks ago. We've had the deeds office that was breached on Uber, not the driving service, but the deeds office. 66 million ID numbers compromised. So what we do from an F5 perspective is when a user is logging on and they request a website, when that website is responding to the user, we inject a bit of JavaScript and we send a public key with it. The JavaScript is used to do what we call HTML obfuscation, which randomly places the login fields in the actual code, and we put decoy fields in there. So the hackers find it very difficult to determine what is legitimate and what's not, what's a decoy field. And then we encrypt the user credentials. I'll show you that in a little bit later. Talking around the bots, I did mention earlier, a lot of traffic these days is bot-related. This is why it's critical that you use a web application firewall, not just to mitigate against the bots, but this can actually bring down the costs of moving to public cloud. If 50% of my traffic is bot-related and I cut that out, the costs of running in public cloud are far less from a bandwidth perspective, from a resource usage perspective in a public cloud. This is those hidden benefits. But more importantly, we're going to cut down on the amount of breaches. 77% of breaches in 2016 involved the use of automated bots. So what did malicious bots do? As I mentioned earlier, it's not just about bad dancing. It's about attacking your mobile and web app infrastructure, launching denial of service attacks, infecting your devices with malware, and tampering with transactions, or what we call automated transactions. We can, as I mentioned, do this behavioral analysis and fingerprinting to make sure that when a user is connecting via a device, we can fingerprint that session, and if anything changes, we know who the original user and device was. Just looking at just an example of how an advanced detection solution works, when somebody requests information from a web server or web application, the F5 appliance responds first. It does not allow the server to respond. It injects some JavaScript, which is a challenge. The user will then respond with that challenge. A bot cannot do that. And then it stamps a cookie and sends a cookie onto that device, which will then talk immediately back to us, so we don't have to do that again. We know it's a legitimate user. So the valid response is then finally sent to the server, and then the server responds with information, and then those continuous invalid bot requests are just blocked, and the user has the challenge request. They don't have to do it again, and they continue to work. From a denial of service perspective, we have denial of service built into a web application firewall by default. This will make sure that, A, we're analyzing the traffic. It'll build a protection baseline to make sure this is how your application should be responding. Am I out of time? Cool. Let's finish up with this. Cool. And then, of course, dynamically create signatures for you on zero-day attacks. If you'd like to see more and talk more about this, I'll be at the F5 stand. Okay. Thank you.